So today what we're going to look at, at least the first thing we're going to look at, is we're going to go into volume now instead of just area. What I have here, this is all circular. I'm just looking at it from the side. It's all round. Call this here 80 millimeters. 12. And we'll call that, we're going to call this angle here 75 degrees. And this is symmetrical, even though my drawing sucks. Thirty millimeters. Come out here. I want to find what we have here. We have cylinders, we have a cone, and then this piece right in here, it actually looks like this. What is referred to as a frustum. Now this is called a frustum of a cone. There's also a frustum of a pyramid. And what it is it's the base of the cone or the pyramid with the tip cut off. So you can imagine that this, in a full cone, it would have come to a tip here. That tip has been cut off to create the frustum. Find its volume, we find the whole cone, then we find the tip and subtract. So let's start off with our first shape. It is a cylinder. We're going to find the area of its base, which is pi times 40 squared. Where did the 40 come from? That's 3. It's half of the 80. $5,024, which it is. Square millimeters. How do we get the volume of that piece from there? Area of the base times what? Thousand. There's one component of our volume. Next, we're going to look at piece 2 here, which is that frustum of the cone that we had mentioned. What do we know about the size of the big base? Millimeters. Good. 80 minus 8 minus 8 on the other side as well. That's 64 millimeters. Now this 75 degrees here is saying that if I made a right triangle, taper angle basically, this angle here is 75 degrees. I know that this side down here, 24 millimeters from up here. What I really need to know how do I find that missing side there? Tangent. 5 degrees equals 24 over, call that A for now. How else do I find A? Over 1, 5. So 1 times 24 is 24, divided by the tangent is 75. Oh, it's 7. Try that again. Point 43, 431. Now we're just going to call it 6. So if that is 6.43, what that tells us, this big end up here is what good does that do us? Start on finding the volume of that frustum. Remember, start by finding the volume of the full cone. How does it find the volume of the full cone? Base. I do this. This angle is still that 75 degrees. But now instead of having the opposite side, what I know here is that this side, 32, half of my diameter, it's just my radius. So I'll call this side side B. And I'm still dealing with the tangent of 75 degrees. It's only now I'm looking for the opposite side instead of the adjacent side. Tangent of 75 times 32. 119.43. Millimeters. So the volume of the full cone, remember how to find the volume of a cone? Off the area of the base, how do we find the area? Base is just going to be the circle. Pi r squared. So pi times, what's the radius here? Perfect, 32. 32 squared. $3215.36. squared is the area of the base. So to find the volume, 3215.36 millimeters squared times what? 1943. Equals 384,000 and 10.44. That is the whole cone. What do we have to subtract off from that? That tip has the diameter 51.16 that we had before. The height is going to be the 119.43 minus the 24. $95.43. And I have to find the volume of that mess. I'll give you a couple minutes in your notes to find that volume. $196,000. 196,072.39. Correct here. Volume of the tip from the volume of the full cone. Get the volume of that frustum. $187,928. So next we go back up to piece number 3, which is just a cylinder. Cylinder. Height of 30 millimeters. Obviously, I didn't draw this to scale very well. And a base with a diameter of 51.16 millimeters. How do I find the volume of that? area of the base is pi r squared, so pi times 25.58 squared. Yes, 2054.62. And upper 1638.6. That one was the easy part. Finally, final cone. The angle in the tip is 30 degrees. So this is 1.16 millimeters. We're going to find the height of that cone, don't we? Even though it's laying on its side, the height is this distance, base to tip. How are we going to find that? A right triangle is found by going from the tip of the cone to the center of the base, making that right triangle. So it's going to cut that 30-degree angle in half, so it's going to be 15. Taking this 20.58 millimeters here is going to be half of the 51.1, 25.58. I call this down here side D. What's D going to be? How do I find D? Tangent again. Tangent of 15 equals 25.58 D. That over 1, and we're going to cross multiply. 25.58 divided by the tangent of 15 is 95.47. Once you find that volume, add the volumes up. See if you get the same number I get. This is 15 degrees. That make this angle. Means this piece here that we cut off, actually that piece there is the same as the tip of the frustum, the cone that we cut off to make the frustum. I didn't even find the area of that cone. I just said instead of using this area or volume, let's use the volume of that full cone and just add those three pieces. Come on, just right around 506,000. You can see the amount of effort that can be saved, though, if you do notice when you have those lake angles and you have those pieces. So up here, if I had noticed that sooner, I wouldn't have even bothered to find the volume of that tip and subtract it. I would have just said, hey, volume of the full cone and split it into the pieces. Covers both of them. Any questions on that one? Kind of awkward viewing it from the side like that. I mean, I've got a problem out there posted where I was really mean. This. And that's around a circular piece. The problem with that is to find that, so you've got to find the volume of this whole cylinder, then you've got to find the volume of that frustum and subtract it. Then you got to find the volume of this whole frustum, then the volume of that frustum and subtract it. Then you got to find the volume of this whole cylinder, subtract out the volume of that cylinder. I decided I don't hate you guys that much. But if you really want to play with it, that example is out there on the worksheet if you don't want to mess around. I guess that depends on how much you hate yourself. If you have family issues that you need to escape from tonight, you know, there's your. So this is similar to those examples we did the other day. It does have depth to it, I just didn't draw in the depth. All I want to do though today is I want to find the volume removed in this. Try and give that a depth of realistically, my main point is just to find the area of that piece. Once we get that area, we're going to multiply it by 24 millimeters to get the volume. I want to find the area of that piece. Do that. We're going to look at a full circle. That piece, let me make my circle. That doesn't help a whole lot. do I know about that segment that's being cut out of that circle? My distance across here. $44 millimeters. That's this distance here. What's this depth here? Oh, 30 minus d18. How then would I go about finding x, the other side of the circle? Zero count. How do you go about finding this speed? X. Perfect. We split that 44 up into two pieces that are the same, 22 times by 22. And yes, the x times 12 equals 22 times 22. If I divide both sides by 12 there, x equals 22 times 22. Well, giving us 40,333. What's the diameter of a circle? Two point three 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 three. 40.333 there plus the 12. So our radius? Divide that 52.3333 in half, we get 26.16666. And now we're ready to play. Remember, finding the area of that segment, what's the next thing we need to do here? Find the angle. How do we find that angle? Got that right triangle. What do I know about that right triangle?
Bottom ones.
Good. We can find that angle. What trig function are we going to use? Sine. Good. Opposite over hypotenuse. So now we're looking for the angle here, so we're going to actually do $57.22 degrees. Is that the angle we want? Multiply that by 2, we get 114.44 degrees. Here we have our sector, the whole pi wedge here. How do I find that? pi, so 3.14, times the 26.1667 squared, times our central angle of 114.44, divided by 360. We have 683.44. Now, what do we have to subtract from that? We have the triangle. This triangle here has a base of 44 millimeters. Its height just be this full radius minus 12. So I do the 26.1667 minus 12, 14, 7. And of course, we still need to, all right, 11.67. .77 millimeters squared once I subtract. That's the area, so then of course the volume area 371.77. Depth was the 24 millimeters. And 22.48. I want to backpedal a little bit, and I want to show you a little bit of a trick for that area of the triangle. Anytime we have a triangle where we have two sides, let's say this is 48 millimeters, and this one down here is 42. And the angle between them, let's call that angle 47 degrees. I can find the area of the triangle as the length of side A times the length of side B times the sine of angle C, as long as C is the angle between them, divided by 2. The area of this triangle here would be 48 times 42 times the sine of 47 degrees, 2. Yes, 737.20. How does that apply up above here? Well, up here I could have done 26.16 here times 26.1667 again, times the sine of that angle, 114.44, and then divided by 2. You notice I get that same area I had there, 311.67. So it's just an extra little formula you can have in your arsenal for, you know, the angle on two sides. In that case, we could find the height rather easily, but you'll run into some cases where there's a worksheet posted in Blackboard again for this stuff. Again, the second problem is similar to the one we did to start off the class. The first one, I'm not going to force you to do it unless you got a masochistic side to you or something. Punish yourself tonight.